Hello everyone. Myself Rohit Kumar and I am doing my PhD from the Bennett University. A PhD student from Bennett University. So today, my presentation, or I am going to learn about the Pylearn2. So basically, if we start about the Pylearn2, what is the Pylearn2 and what is the basic use of Pylearn2? So before starting, I want to tell you that the Pylearn2 is a machine learning research library, and it is developed by Lisa at the University of Montreal. So the basic goal of this library means to facilitate machine learning research. So its goal is machine learning research, and the main focus on this is the flexibility and the extensibility. So to learn about the what is the Pylearn2, so we can say we can start from the Pylearn2. So Pylearn2, as mentioned here, the Pylearn2 is a library that designed to make a machine learning very easy. The first thing. The next thing is there, the Pylearn2 is designed to be easily reconfigurable to perform a wide range of possible machine learning experiments. So various possible machine learning experiments like using support vector machine, unique regression problems, support multi-layer perceptron. These various problems are in machine learning that can be used by using the Pylearn2. And the Pylearn2 also contain the classes for the working with several common machine learning benchmark datasets. So various classes are there. The first class can be we can say the first class is dataset class, machine and training classes, implementation models, the model class, implementation dataset, and the training algorithms class. So various classes are there in the Pylearn2 using Pylearn2. So it contains various classes. So serial communication, and the challenge is one challenge becomes in Pylearn2 is to load a third-party data set into Pylearn2. So it's a challenge for the Pylearn2 to load a third-party data set, and it is also used to solve as regression problems. So basically, mainly using the regression to solve regression problem. In the next slide, we will see that what is the regression. I will explain in detail. So continued with the what is the Pylearn2. As I said, it's a machine learning research library for the researcher, and it is built on the top of the Theano. So Theano is all the research libraries. So it's built on the top of the Theano. So you can if you have some knowledge of the basic of the Theano, it can be used very in a fast and efficient manner. Easy to try variants of implementation algorithms. I have told earlier that various variants of the implementation algorithms, SVM, multi-layer perceptron, and convolutional networks, various algorithms, and extend them using Theano. Very modular. Each component of the library can be used in isolation. Each component sufficient um, to solve any problems using Pylearn2, and various experiments can be specified through a YAML configurable file or a Python script. So either we have a YAML.YAML file, or I have a Python script. Both are the options for the need for being experimental things. And the script for visualization, weight, plot, monitored values, these things are there. It's easy for the scientific experimentations, and researchers add features as they need them. So because Pylearn2 they have started in the 2010, they have in late of 2010 the series of community have started working about the Pylearn2, and a class project in early in 2011 by the Lisa, and 2013 it's again being a community, Lisa community, and they have their first half of the 2013. So it's significant user base outside the Lisa in the first half of 2013 came the Pylearn2. The philosophy behind the Pylearn2 is the machine learning research library is built and reusable part that can be used in many combination independently. Pylearn also avoids the over planning. It's basically a domain specific language, so that provides the compact way for the all experiment. specific for the hyperparameter or all parameters. So if you talk about the research library overview, the what's the Pylearn2? So many deep learning references implementations to provide the greater flexibility and make it possible using the Pylearn2. So many small frameworks that are the MLP, RVM, uh, SDA, the convolutional networks, machine learning problems. So various small frameworks what are needed for the normal things are there. We can write the Pylearn2 plugins, new models, algorithms using the machine mathematical expression. Many deep learning references, implementations. So about the Pylearn2. When we talk about what is the regression, we have discussed in the slide per second. What's the regression? It is used to solve a regression problem, basically. So if we talk about what is regression, regression is basically a machine learning problem in which we have to achieve the y. Y is our output, but we have some x values there, some input variable x. So in the regression, both can be a vector, both is a, both must be a vector. So both x, y may be a vector value variable. For example, they may contain a set of multiple experiments rather than just one measurement. So if we take an example, okay, say a company that will make of a red wine and its pH value of alcohol content, these are contained as a sample of this. So such pH or alcohol, these are the X, and Y is a subjective measure of its quality. If the quality is good or bad or something else. To solve this regression problem, we just machine learning model, they can accept predict quality of a new sample. Suppose a new sample comes and we have some parameter pH value alcohol previously. To judge a new pattern, a new unseen pattern comes, and what is the quality of this unseen pattern? It can be Y, it can be no, it can be what it can be. So it's a problem of regression. So that okay, using we train our machine or we train our machine with this some previous you can say that previous training set, and using when the machine is trained with this training set and unseen pattern comes, then what it is the prediction of this unseen pattern, can be Y or no, something or red wine is good or bad, something good. So as the line said that can predict the quality of a new sample of wine that have not been rated a human yet. It means that it's a completely a new things comes always to test the things that okay, our machine is trained good or bad, or which parameter, which features the machine have. So if it correctly classified that okay, it's correctly classified, so training is best. So key benefit of the Pylearn2, the training algorithm, stochastic, batch, GD model, specific. So these things we can easily understand, and it is also using, you can say that training cost, supervised, unsupervised, exact estimation, NL, natural language processing, score matching, and the termination criteria that we have to when we have to stop the training, because a lot of training if our input features are repeating again, or we have something providing the same feature as the previous we have. So termination criteria, we have to stop the training extension to perform action through the training processes. Early stopping if we want to early stop. So models, various modelings. The three things are there in the Pylearn2. The first model, the second thing is the data set, and the third is the preprocessor. So model, neural networks model, the convolutional networks model, the RVMs, the K-means, the PCA, and the SCM support vector machines, and the data set, example the MNIST data set, the CIA part1n data set, basically a data set of thousands of images of birds, aeroplanes, these images data set, very heavily say 150 to 160 MB data set, the CIA part1n, and it's basically using the Pylearn2. And the preprocessor, the LCN ZCA. Data specifications, semantics to the data means the index space, vector space, conventional 2D space. So basically index space is a 1D integer array, that's what they're using for the labels. Vector space is a float array, 1D one-dimensional float array, and example is the float softmax output. Software regression is a problem that we can solve in the next slide. using the Pylearn2. So for the softmax output, we take a vector space. The conventional 2D space basically is a 3D float 32 array and for the color image input. YAML files, there I previously said the YAML allows the experiment to be conducted without writing code. Without writing code, the YAML file. It's a say Python file, so we can create a .yaml file and about the standard data set MNIST and the CIFAR data set, a standard data set. So it is about the data specification, and the next is how to install the Python2 package with the Anaconda you are installing if you have the Anaconda things are there. So how can you install with Anaconda 2 if the Python things are there? So we can easily think that okay, the Conda install minus Python C, Anaconda and the Pylearn2. So we can easily store the Pylearn2 packages with the Pylearn2 packages. In the next slide, we will see the technical specifications after the when we have a researcher, we have the script. In this part of the script, we have Pylearn2 libraries. Using the Pylearn2 libraries, how can the machine learning algorithms can be we can say solve various problems using machine learning algorithm using Pylearn2. So what is in this video we have seen that okay about the Pylearn2, what is the Pylearn2 things are there, what is the machine learning research library, what is the Pylearn2's data specification, what is the regression is there, the key benefits of the Pylearn2, what the meaning based in the models, the neural networks model, the various model data set to standard data set, MNIST and the CIFAR10, termination stopping, these things. And then in the next slide, we will see about the Pylearn2, the specifications about the Pylearn2 in the technical aspect. So thank you all for watching this video.